Well, thank you all for having me here. Today I'm going to be talking about perfection at the connection. What does that mean? It means perfect information at the point of attachment. When you're thinking about an assembly line, and we're here in construction, we don't always think about our projects as assembly lines, but that assembly line worker has perfect information. They know exactly what part is going to go where. There's no layout. Every piece fits on top of the other one. There's no RFIs. Can you only imagine what your construction jobs would be like if every worker if we were timing things down to 78 seconds at their workstations for each installation of parts, just like a Toyota car at the Georgetown plant. When I started 25 years ago, I got into layout about 24 years ago. I was using a T1, a wild T1 with an HP 42S, and that was the most powerful computer that we had on the job site along with the fax machine. I couldn't have imagined how far we've come today. When I look at today and what's going to happen here in the next few years, I think we'll move at a more exponential rate. With that in mind, I do see that our construction jobs can be an assembly line with this BIM technology. Right now on an assembly line, we would talk about these questions, but cross out assembly line and insert every object on a construction project has a description of what it is, has a location of where is it going to go, who's going to be installing it, and has a process chart. Do you imagine every object that you look at on a job site has a specific process for its installation and its movement? And those are separate. And we can also install it at a faster tempo. You can't be in Texas and not talk about football. We've all seen what Chip Kelly has done for Oregon football, and I know there's some Texas A&M guys out here for the spread offense in a faster rate. Can you imagine building that fast? And we can. Perfect information at the point of attachment allows our workers, through your work with BIM, to not only be skilled craftspeople, but to be knowledge workers. Something that Peter Drucker talked about years ago as a separation. But the majority of the times, they don't know where these parts and pieces are going to go. A few years ago, I put this together with a friend of mine who's an architect, and we talked a lot about building. You know, building's very linear. 1, 2, 3, we put the parts in, we start at mass excavation, and we finish at C of O, and put our parts in together. Tim started drawing out, and he said, Chris, you don't understand. Architecture is a very iterative process. The squiggly lines there. We don't know where all the answers are going to come, and it takes time to get there. And I said to him, Tim, with BIM, I can pick off the answers. If you give me 6, we can start to build that offsite. You give me 5, I can start to build that. We can slide these parts and pieces in. It ended up being what we called was consign. It was an integration. But also greater than that, the model is, and with the sociological part, is where we come together. You know, you really got to start to think of this model. We always talk about the 3 parts of the stool: the owner, the architect or designer, and the contractor. BIM is the medium that we all come together. We used to come together at the point of building. Now we can come together sooner. And with IPD, you start to realize that we all really want the same thing, but we look and communicate at the world differently. But BIM is that common factor that can bring us together and is improving this world. One of the other things you start to think about when you start looking at this is the cost of quality, right? You can have it fast, you can have it cheap, or you can have it good, but you can't have all 3. I would also put to you that BIM will give you all 3. Will give you the greatest value in the shortest amount of time. I did a study for my black belt on RFIs. Some people were looking at RFIs as they wanted to process them quicker. I wanted to cut them down. In my study, we started looking at it, an RFI that doesn't really affect anything, but just the processing time of it was $771. When you really start to think about that, think about the math on your job. I looked at Turner, $7 billion worth of projects that we did samples on. That number, if you take it, total project cost, started to come out somewhere between 1.5 and 0.8%. For those of us that are general contractors, that's some serious money. The other thing that we really started to look at is, again, punch list, contingency. Can you imagine a job where we didn't have to have contingency, where we didn't have to have errors? John talked a little bit about rework. So what do? We look at this, start to look at this differently. We start to look at the process of building. What you're looking at here is just a high-level process chart. We've got to take what a client wants. A designer needs to put that together to think about how it's all going to be transmitted. But again, we're trying to transmit intent into that builder all the way along. BIM is changing the way in which we're doing this. We start to think about that there's a point at which we go from electrons to atoms. We can also look at this differently in the supply chain and start to apply industrial engineering and production to it. Did you ever realize that for the majority of all our materials, from the factory to the job site, they all do the same thing? They're all loaded into a truck, they travel to the job site, they're offloaded, and they're attached. BIM allows us to start to see these patterns, to give us more of a holistic look instead of it just being our job site. How many people think every job is different? That's it? Okay. How many people think every job's the same with a certain amount of difference to it? Right. And if you're over 50%, I want to leverage that sameness. I would put to you, BIM gives us the concept and the vision to start to see how similar all these jobs are. This gets us into an integrated model. This was an interesting story. We put a schedule together. The client had asked us to take 169 days out of a schedule that didn't have 169 days to take out of it. And there was no changing it. So the story was, we're going to model everything. I used to say we modeled everything but the paint, and then when we messed the paint up, after that I said we'll model the paint next time. As starting out doing survey, and as a carpenter years ago, and doing the math by hand, and then starting out with Next generic CAD, I always realized that the math is the only perfect thing in construction. And that's where it starts. There's an infinite number of points in here. For the designers, they look at it as positive and negative space. I look that I can write an equation for anything, as long as it's not a polyline. And as we moved through this, we made the model the field, and the field the model. In the lower left-hand corner, we had a difficult connection with some huge embeds. We were concerned about congestion. We knew that the anchor bolts had to be perfect. So again, we modeled everything. We modeled it as it was going to be built. We worked with the design. And you can see over in the lower right-hand corner, we came up with a more effective prefabricated insert, and the bolts fit. Another story of we got to the point of moving ahead with this is we started calling this built to design, right? You know, this is changing the way we speak of this. Think about this. As-builts are a measure of failure. Okay? They're a failure of the design to be built or the design to be buildable. I can now say to my design friends, if you draw it, I will build it. Put the lines in. There's no field verify anymore. Okay? There's no design intent on a 2-foot by 2-foot piece of AC plywood, right? Now imagine that we are moving towards no design intent on $200 million complex lab buildings. Wouldn't that be a great thing? I don't hear design intent as much anymore. Okay? Again, perfection at the connection. The skilled crafts can focus on attachment. The question was said to me last night, I think we're losing the craftsmanship with this, with all this prefabrication. The one thing I thought was interesting about it was, how's craftsmanship having a dirty, disorganized job where a worker can't finish the work, really craftsmanship? The lower right-hand corner is the Rolls-Royce factory. We all know that those 40,000 parts that are in every Rolls-Royce are all modeled. Some of the greatest craftsmanship in the world. I try to set our workers up for success. They're geniuses at putting parts and pieces in, but we've hampered them in certain cases by not always giving them the right information. When you free them from that, they have to use that creativity somewhere, and they use it into better industrial engineering. Electrons to atoms. This is one of the things that I think is so interesting and really pushing the business forward. We used to start out, when we first started out, and I was doing a job with Jan in 2005, a BIM job, we had the section where people were modeling. But how do you get that information to the field? How many times have you done a great MEP coordination model, and they go out to build it, and then ceiling grid starts to go in, and somebody says it's too low. And everybody goes, what happened? Well, they all measured off the floor. Well, you can't do, and then the client says, well, why did we model it? I spent all this money on modeling, and now it's wrong. Everything in the old days went back to grid. Today, everything goes to the coordinates. The coordinates match. This is one of the keys. On the latest job that we've got 11 different trades using total stations. For the first 7, I won't even contract with you if you don't have a total station taking your BIM model to the field. Okay? Everything goes back to the coordinates. For the lawyers in the room, because I can remember this a long time ago, the coordinates are the ultimate. If you change the coordinate, then the model has changed. That number is the unique identifier. No two X, Y, and Z coordinates can ever occupy the same space at the same time. The other part, too, of tying the model to the field, we do have to get back to fundamentals. Again, back to the X, Y, and Z coordinates. The interesting part about layout is once you start speeding it up, once you don't have to type in the X, Y coordinates for those targets in your HP42S anymore, and you click on them and you go from point to point, that labeling becomes the slowest thing out there. In this particular case, we had to speed things up. You got to have a clean floor. It's got to be dry, and you got to have a label. Use your data again. Don't have the guys label. Pre-print the labels. Those creative guys in the field, those 7 trades out there, now their points are all color-coded. So each trade's got a colored label on it. They can walk out there. Can you imagine pouring your floor the next day, 7 total stations on the floor, all the layout done at once? They're going 460 points a day. This was an interesting concept, and we had to change it. You know, you think about the old days of plumbing steel. We're only plumbing the steel in one direction, either X or Y, right? We had to come up with a new concept. We can't call it plumbing steel anymore. We call it positioning to design. We've got 1,800 points on this particular job. Big shout out to Lika there. And our guys are positioning the steel exactly where it needs to be. All the edge form, you can see up in the upper right-hand corner, came out pre-welded, was fabricated at the shop. The tolerance that this is all being put in is within plus or minus 1/4 of an inch. It does start to get to the point where you're speeding this up, and it's getting to be like an assembly line. We're taking the points out of the model and we're bringing them back into the model. Virtual is becoming reality. You can see the coordinate there on the steel, and you can see the other point that was brought back into the model. Field verify. We field verified at this point, the one inside the model there, at drywall. The other part about this is really start to think about installation qualification work in place. You can't shoot it if it's not installed. How many times as contractors do we pay for work and then find out it was in the wrong spot? Can you imagine the next phase of this? Is it your coordinates that you know, especially for odd-shaped things such as VAV boxes, FATUs, AHUs, having specific coordinates in the model that will be the register point for it going in the field. Then when it's in the field, it's shot. You can tie that point to the value of that work and know that that work was installed in place. Subcontractors might like that because we wouldn't have to have retention anymore. What are the results? On that job that we had to take 169 days out of the schedule, you can see up in the upper right-hand corner, week 4, week 11, 90,000 square feet of slab on grade installed, 1,378 precast foundation panels put in 2.5 days. Again, your external setup. 90,000 square feet of post-tension slab done. No blockouts in the wrong spot, and 121 column anchor bolts installed, all perfect. Week 13, 2,310 pieces of steel installed in 100 hours. By week 29, 206 exterior panels installed in 15 shifts, done off-site. This is in the winter in Seattle. It rains. All the waterproofing was already installed on the panel. You can see that they got to the point of just peeling it back. When we free them up, they get very creative on things to do. 468 glass panels installed in 17 shifts. The level of detail that we got to this was we set again, the second most perfect thing on construction is glass. And we had the window openings set the rough openings. And we told the drywaller we didn't even want the heads of the screws in that area. This is the level of detail you can start to get to. These are the things that you can start to think about when you're applying BIM. Performance indicators, manpower down by 33%. Less dilution of management. In Seattle, $25,000 to $30,000 per man month is pretty good. That job averaged $41,000 per man month and peaked at 77. When you start to think about this, we got to look at the metrics a little bit differently. Think about man hours per square foot. That way you can measure it against space and time. We'll go a little bit back in history and a little bit later. Empire State Building, took them 2.5 man hours per square foot for the best information that I was able to get. On this one, we did it for 1.5. It's not a lot of improvement, unfortunately. CFE did a study, started one in 2009. What would it take to build at 1,000 square feet per day? That's what they do a 737 at Boeing. So imagine your job that you're on from the time that the mass excavation is complete, divide it by 1,000, and that's how many shifts you have to build it. We were able to do that job at 1,068 square feet per day, Class A office space, turn the key, hand it over, and they moved in 5 days later. On that job, we also said model everything but the paint. At the beginning, the client didn't believe in it, but they had no choice. They do it. At the end, Mike goes around with his lawyer suggesting to everybody that they should model it. And when we had a couple mistakes and we hadn't modeled it, he reminded us of it. With this, we get some different analytics, really start to measure things differently. With John being from Boston and how this all started for me, it started with, and my family being from New England, sabermetrics and measuring things. And we really started getting into measuring productivity. And this is just an example of it. We measure everything. We now pick those parts and pieces and measure them as they go in. We're finding new ways to slice data. And with this, we'll be able to slice data even more effectively. I heard the other day somebody said that the most popular pie in America is apple, but that's only for an 11-inch pie. Now that they have individual pies, it's like 4th or 5th. The point of that is this. Back when we could only do 11-inch pies, apple's the most popular. Now that we can do it individually, that's not what we want. Big data now that we're getting into, the data will change. The data won't change, but since we can slice and dice it, we're learning new things. I love the swim lanes. I'm big on swim lanes also. So back to our assembly line approach and taking a look at swim lanes and looking at how the job is set up. Most contractors look at the flow of work. And this particular one, on this particular job was a hospital. We looked at that level of complexity. The orange section is the procedure rooms, blue is admit and recovery, and the red is a hallway. We set up the design, the BIM coordination, the construction, and the turnover all through those swim lanes, and they followed that same cadence. And all the way into the build. So we've talked a lot about single piece flow with lean. Think about construction as single square foot flow. That the square foot that you're standing in, because the workers move past that point of work, and what is going to go on in that square foot. It allows you to schedule things differently. It also, when you think about our assembly line is three-dimensional. We always have this z-axis where we have to move up and down. Really push and think about those, how many times are we going up to those parts and pieces, and how can we reduce that? The other thing that I think is important and doesn't get a lot of credit is the I part, is the information in BIM. Did you ever think about this, that there's a supply chain of information? You know, your TV dinners come with the directions written on it. Can you imagine your drywall coming with the directions on it, and is that worthwhile? But let's look at these lights here. When you think about that, the light, it has to be designed, estimated, scheduled, purchased, submittals, BIM, detailing, task-based, process chart, last planner, fabrication, receiving, installation, qualification, billing, inspection, special inspection, startup, commissioning, punch list, owner training, and maintenance. That's a lot of times, and we throw that information away, reuse it. When you talk about, you know, we do prefabrication, but do we just throw it, after we prefabricate it, do we just throw it in a box, send it out to the field and have them resort it, have a drawing on it that they have to figure out where does it go? The information is there, don't lose it, okay? Don't focus on your handoffs of information. The other thing that's interesting about assembly lines, we give a lot of credit to Ford for starting the assembly line, but it was Eli Whitney who developed interchangeable parts. And Ford would not have gotten to the place that he did, and we wouldn't be where we're at today without that. Also think about information as interchangeable. If you're doing a job in Ithaca, New York on a biplane for Phillips, and you're doing a job in Texas for a biplane for Phillips, I'm sure there's interchangeable BIM model pieces that are there. Start to think about what are those repeatable patterns. Items are location specific in the model. Also, it's important to think about the bulk items that come in that aren't location specific. So meaning, you can't put anything in the model that doesn't have a specific location and that we can't get the information out of it. How many times do we send stuff out to the field that we're not quite sure where it's going to go? With that, it takes us to the next part, is barcode tracking. It's just another way of efficiently using the data. The part on this would be is really thinking about your division 9, 15, and 16 and those locations. Think about those schedules and what goes in those rooms and how can we efficiently get that information. Field model integration. We do a lot with laser scanning. This was an interesting story in that in this particular case, where we took our total stations, had the the model and the AutoCAD drawing for where the floor plate was going to go, actually laid out, did a topo specific to exact locations, found the most efficient elevation to put the entire model at, and then raised the model at DD, which was much to the palpitation of my architect friend, but it all worked out fine. This also creates a paradigm shift in our thinking. Think about single pass construction. Just a quick example. Sprinkler lines. How many times do the sprinkler lines come in? They do their arm overs, they run them long, they come back, drywall goes in, they're waiting for the lights to figure out exactly where they're going to go. We have to move some studs and some track because they're not in the right spot. Everything doesn't line up. Single pass construction with X, Y, and Z coordinates with nothing measured off the floor, they can come in very first, run high, arm over, and put their heads in all in one shot. How efficient is that? You know, remember this, the word align. If it's X or Y coordinate equal the same number, it's aligned. It doesn't make it time, you don't have to be time-based anymore. And we've done this on jobs. It was interesting, John's point on waste. As GCs, when we would start to think about this, you know, 15 to 20% of material fabricated on site, that takes diesel and fuel to bring it to the job site. That takes power to 33% of all our manpower on the job site, in most cases, is moving material. So you're moving an extra 15 to 20% in, you're moving an extra 15 to 20% out for your cranes, your man lifts, your forklifts, and then we're throwing it all out. With this, we only want to bring to the job site what we're going to install. When you model everything, all the studs come pre-cut. It's all like structural steel. We were able to drop this. You can see the numbers that we got to with our target 0. Back to our assembly line. The other thing that was great about Ford was all the work came to the workers. So what's that mean? We all walk at roughly 240 feet per minute at sea level. Okay? So we're trying to cut down on the walking. Our crane moves at 300 feet per minute. We have a mechanical advantage there with our crane, and we're utilizing it. Our cranes, our man lifts, those are our assembly lines. Our trucks, we're trying to move that as efficiently as possible. The other one that's interesting about it too was, and back to the our productivity, I sometimes wonder if that had to do with HVAC. I read an interesting thing as I was prepared for this. In 1911, chocolate factories started to realize that they were more efficient when they had HVAC, when they put HVAC, or not HVAC, but cooling into their warehouses and shops. They also realized that the productivity increased. It's 90 degrees and humid out here. It's 65 and not humid in Seattle. I would expect that a carpenter in Seattle is probably more efficient than a carpenter here in Texas, simply because of the weather. When you do your assembly off-site, which BIM gives you the possibilities to do in a climate controlled, in Seattle we don't have to fight the rain or the snow or allowing us to have better light. So what's that put us into? We really got to start thinking about melding man and machine. What's exciting about what we're doing today is the technology that we have now, but we needed to get back to the place of, you know, with all this work coming, more efficiency in workers. So I did some research and went back to where it all started in the U.S. In the late 1900s, earliest 20th century, the productivity revolution. The Gilbreths were instrumental in improving worker efficiency. You know, 6,000 years ago, a brick was the first interchangeable part, and Gilbreth started working on motion study. These are the things that we're working at today, and BIM gives us the ability to really focus on that. Gilbreth developed, with his motion study, 17 individual motions that set us up for more efficient process charts. Again, back in Texas, high school football is king, right? I would put to you that The high school football players of today spend more time talking about their foot placement for blocking schemes than we do with any of our tradespeople that are working on our job sites. However, in 1911, Gilbreth was marking out what exactly the foot placement should be. We're not taking advantage of modern ergonomics. We should look at these things. We can look at reducing worker fatigue. We're not working faster or harder, we're working smarter. What's that allow us to do? With looking at these individual parts, we have this higher quality, we start putting process charts to everything that we've got. We can handle this data. We can get down into the weeds today because of BIM, because of the information. I have this clicker here. It signals, it gives me there's a process chart for it. It tells me what to do. I know what I'm going to do with that. You can think about your drywall, you can think about your pipes, you can think about anything like that. With that, we start to think about repeating patterns. It's interesting that sub-Saharan Africa, all of their villages are fractal based. Ron English did some studies on it, and it's a great TED Talk. It really got me to think about patterns and looking for patterns. We all know that once you get to the 4th floor, you get on cycle in an apartment building or a hotel, it starts going a lot faster because everybody knows what they're doing. Well, think about that. How much more productive would we be if we knew everything on the 1st floor? The modeling gives us that ability to do that, to start to look for those patterns and make your first day productivity as great as your second day or your third or your fourth. The other part that's there is from a 1968 paper, again with patterns of work. Start to think about what you're doing. We do the same thing. This is for a carpenter. Goes to the stockpile, picks up a piece, goes back to the point of work, measures, cuts, fits, installs, and then goes back. I would put to you that almost every tradesperson does the same thing. Pattern recognition again, Revit families, they're patterns. This is an actual from a job that we've got right now. We mine the data looking for those patterns. We're looking for those repeatable parts. We're trying to make your offsite prefabrication as large as possible and cut down on those parts, and BIM allows us to do that. With that, you have to synchronize your supply chain. We talked about that earlier in order to build at these rates of speed. With that, with all these parts and pieces coming at them that fast, we had to look at how do people think. Well, we had to start thinking about fighter pilots. Situational awareness. It's not a learning curve. Tasks, we don't have learning curves. We have situational awareness curves. John Boyd, fighter pilot for the U.S. Air Force, was the one who developed the OODA loop. It's the way in which we all think, speed of thought. You see it now in football. Chip Kelly, Oregon, the spread, it's all the same way. We took it on the construction site to make sure that our guys were able to think as fast as possible. We wanted them oriented, give them the ability to decide and act. First day productivity is the same as second day productivity. You can see the iron worker below. We talked about the information not being lost. There's a north arrow. We had to start making sure that the information written on things was large enough that they could pick it up quick enough, because sight became an issue. We had the center of gravity measured. Since it's on at the factory, we had it measured, put on at the factory, so they don't have to do that. We're cutting down on wasted motion and actions. Cue the video. So what's that get you? It gets you the ability to put work in place in tighter areas, synchronizing men and machines as fast as you possibly can. We're pushing the edge of fatigue. On our job sites, we have to have bottled water for the guys. We're giving them goo because they're getting mentally and physically tired because they're moving at this fast. In this particular project, we put the cranes in close proximity, we synchronize them, and we've been able to erect steel at twice the normal rate. In this particular project, we poured a deck 9 days after the steel had started. We're up to the 6th floor and a sister building using a single crane. When they were only to the 6th floor at 1 month, we're erected out and poured out on the 6th floor. 2,986 pieces of steel erected, 10 floors decked, stairs on all 11, 2 floors poured, 1 floor fireproofed, 300 deliveries. BIM is changing the way in which we do business. It's changing the way we think about construction. The goal of perfect information means building in less time, less waste, greater quality, and greater value. Thank you very much.